Okay, today we're going to be filling in a foldable to review the differences between theoretical and experimental probabilities. So make sure that you've got in the foldable and that you've glued it in to your notebook. And as you are watching this video, you're filling it in along with me. So again, it's on theoretical and experimental probability. Okay. The first thing we're going to talk about is to define probability again. So probability is a number from 0 to 1 that tells you how likely something is to happen. So it's basically telling you the chance that something is going to occur. Okay, so most of our problems are going to have to do with this spinner right here. We're trying to figure out the probability of spinning the spinner. So what could or couldn't happen when we spin it. So first we're going to talk about the theoretical probability. So theoretical sounds like the word theory because that's what it is. It's in theory what should or what is expected to happen. So the definition is theoretical probability is what is expected to happen. To find it, we find the number of favorable outcomes over the total number of possible outcomes. And this P right here in front, all it does is stand for the probability, where the E is the event, like what we want to happen, getting an A on the spinner, getting a head on a coin, getting a 6 on a dice. Okay, so for example, if we were to toss a coin and getting heads or tails is 1/2. The reason that it's 1/2 is because the probability of getting a head is 1 number of times you could get a head out of 2 total options. Same thing for probability of tails. There's 1 tail on the coin and 2 possibilities. Okay, so we are going to find the theoretical probability of our 4 letters. So the probability of getting an A, first we're going to count our A's. So in the spinner, there are 8 total spaces, and there are 1, 2, 3, 4 A's. So the number of favorable outcomes, we want to get an A, and there's 4 ways we can do it. And then there's 8 possible outcomes, so it's 4 over 8. Or we can simplify that down to 1 out of 2. It's also easier to compare probabilities sometimes when they're written as percents. So we know from our builders that 1/2 is 50%. The next one we want to find the probability of is B. Again, P stands for probability. So let's count the B's on the spinner. There are 1, 2 B's on the spinner. So the probability of spinning a B is 2 over 8. Or we can say 1/4. Or 25%. So there's a higher chance of getting an A. But again, this is in theory. So if we actually were to spin the spinner, that may not be what happened. The next letter we want to find the probability of is the probability of spinning a C. So if we go back to our spinner, there's only 1 C, still out of 8, because there's 8 possible. So it's 1/8, or we can say 12.5%. Okay. So again, getting a C, not as likely as getting an A, still not as likely as getting a B. And then the last letter is D. So the probability of getting a D, there's only 1 D. So our probability is the same as getting a C, which is 1 out of 8. Or we can again say 12.5%. Just sometimes when you're comparing probabilities, it's easier to write it as a percent. It's also more common what people will say. If you say you have a 50% chance of happening versus saying you have a 4/8 chance, most people will recognize the 50%. All right, so on to experimental probability. So experimental probability is found by repeating an experiment and observing the outcomes. So in order to find experimental probability, you have to actually do an experiment. You cannot just look at the spinner and say, oh, that's the experimental probability. You actually have to spin the spinner, roll a dice, flip a coin. So it's determined by doing, which is how you find it. The number of times something actually occurred out of the number of times of trials, which is the number of times you did it. So for example, we tossed a coin 10 times, recorded heads 3 times, and tails 7. So the probability of getting a head would be 3 out of 10. 3 times we got it, 10 times we flipped the coin. Tails would be 7 out of 10. We got 7 tails out of 10 different trials. Now notice, it doesn't match theoretical. Theoretical said we would get 1/2. Okay? So now we are going to run our own experiment with our spinner. We're going to spin the spinner 8 times and see what letters come up and then find the experimental probability. So in the first spin, I get an A. Find my pen here. First spin, I got an A. Second spin, I got another A. So this is why it's important to make sure that I do my experiment more than twice. The third spin, I got a B. Fourth spin, I got another B. Okay, I'm going to spin it. That's half my spins. I'm going to spin it again to see if it changes. I got a D this time. Okay, another D. Well, that already, now I'm going to spin it 8 times. I already got one more D than I expected to get. This time I got another A. And we're going to spin it one last time. I got another A. So now let's look at our experimental probability. So, probability of getting an A, I got 1, 2, 3, 4 A's. So 4 out of 8. Or 50%. That actually matches my theoretical probability. Happens sometimes, not all the time. B, I got 2 B's. So it'd be 2 out of 8. Or equals 25% because it's 1/4. C's, I got 0. So we're going to say 0 out of 8. Or 0%. So I should have, according to theoretical probability, gotten at least 1 C, but I did not. And then D's, I got 2, so it's 2 out of 8, which is 1 more than what I would expect for getting D according to experimental or theoretical. That's why experimental is different than theoretical. Theory, what should happen, experimental, what actually did. So now let's compare the likelihood. So which one is more likely to occur? Okay, so that's done on our scale. Notice it even gives us like values. This is important to realize. So something that's impossible, couldn't happen, or 0%. Unlikely, it's got to be between 0 and 1/2. Even, exactly 1/2. Sometimes we say as likely as not likely. Likely, between 1/2 and 1, and 100% is certain. So which one is more likely? So the theoretical probability of getting A versus the experimental probability of getting A, we actually got them to be equal. So which one's more likely? In our experiment, neither was more likely, because we got the same exact probability. And that actually happened for the theoretical probability of B or the experimental. So it's the same answer. So which one's more likely? Neither. So you would just compare the fractions or the percents for each experiment versus their theoretical to see which one's more likely. So now that you are done watching the video, the next thing that you need to do is get an activity where you're going to spin a spinner and roll a dice electronically to come up with some experimental versus theoretical probabilities. If you and another person in the room is done, you can both work together on the activity, but you both have to be done with the video.